Welcome. Yesterday the Sun produced an M3 flare in the complex of active regions in the northeast. You can see them here in the background picture. The M3 flare you can see on the picture as a brightening mainly in the leading part of that region, and then a small brightening in the trailing area as well. So this video is going to show you some of the detail from different wavelengths of how that flare occurred. The flare that occurred is a M3.1 flare, and it peaked at 1212 UT. You can see it here on the X-ray light curve from the GOES X-ray monitor. It came from the Sunspot region, active region 3311 in the northeast, as is shown here with the blue arrows. So what we're going to do now is we're going to go to various wavelengths that are available to us to take a look at what they look like at different temperatures. Around each sunspot region there's usually an area called Plage. These are bright areas which are emitting more radiation than the sunspots. To look at those we use the 1700 angstrom continuum channel from the Solar Dynamics Observatory AIA instrument. You can see here the sunspots clearly and the Plage are the bright areas, but also the flares show up as little brightenings within those regions, so you can see where the flares are occurring with respect to those sunspots. Here comes the flare. So let's take a look at some movies. We'll start at the surface of the sun and then move outwards and upwards in temperature. So we're starting with the Sunspot movie from the Solar Dynamics HMI instrument, which has a characteristic temperature of about 5,000 degrees. You're not going to see much change in the sunspots when the flare occurs. We move up in temperature now to about 630,000 degrees Kelvin. That enables us to see the lower corona using the iron 9 171 angstrom channel from AIA. Here you can see magnetic loops, interconnections between regions, changes in those, and also the dynamics of the regions. The first thing you're going to notice here is lots of little brightenings and some of the magnetic loops reconfigured. Now we're going to look at the active regions themselves. These are the regions above the sunspots, and we're going to use the iron 16 line at 335 angstroms from the AIA instruments. The typical temperature here is about 2.5 million degrees Kelvin. So you'll see the active regions, and you'll see some of the flares as brightenings in those active regions. The hottest temperature that the AIA instrument can see is the iron 20 line at 131 angstroms. So this is really good at looking at flares because the temperature maximum of that particular line is about 10 million degrees Kelvin. Next, we'll take a look at the Soho Lasko C2 instruments data. That is the high-resolution images of the inner corona. It's done in visible light, so this is light scattering off the material as it moves away from the sun, and of course it shows coronal mass ejections very clearly, which is what we're really after here. We do see a CME at about the right time, but it's in the southeast, not the north. The flare occurs about now. Well, what conclusions can we draw from all of this? This sunspot region has been one of the most productive sunspot regions so far this cycle. we've had nearly 50 M flares in the last 4 weeks, which is about one solar rotation. And many of those 50 have come from this one region. The interesting thing is that we've had no X flares. You'd expect about 1 X flare for every 10 M flares, and we're well below that ratio now because we haven't had any X flares. But none of them, interestingly enough, seems to have produced a coronal mass ejection, or at least we can't definitively link a particular CME to a particular flare. That is a little strange. So thanks for watching, and if you enjoyed this, please pass it on to your friends and colleagues who might enjoy this expose of what's going on the sun. And until next time, stay safe and goodbye.